1986 truly was a momentous year for me. At the start of it, I'd attended the IEEE Working Conference on Current Measurement at AiA House in Virginia, a truly splendid location for thinking and for talking with colleagues. And at that time, listed on the left, were listed the papers, summaries of the papers given by a number of people on Doppler profilers. And it was really clear to me at that time that this was a technology that was moving on at pace, and that working in isolation in the lab in the UK, I really could not make sufficient progress. Note that by that time that Fran and Kent, working with Lee Gordon, were already working on a pulse-to-pulse coherent Doppler profiler. Tremendous advances, their paper of 1979. And I took away that I needed to stop my own development and to invest in commercial systems, and especially the commercial shipboard systems from RD Instruments, and learn how to use them. So by the end of 1986, we had bought and fitted 3 shipboard Doppler profilers to the UK's research vessel fleet of Discovery, Charles, Darwin, and Challenger. Some were using synchrogyros. The old Discovery still had a stepper gyro, and the transducer was installed on that sonar pod that you saw earlier. Many of the highlights from the early years of these Doppler profilers are still important on the calibration procedure that was established by my colleagues Pollard and Reed. Scientific outcomes started to come through with volume transport estimates through the Fairer Bank Channel to the northwest of the UK, and also the transport of the Agulhas current by James Luyten of Woods Hole on our ship Discovery operating off South Africa. And process studies, for instance, on internal waves in the Bay of Biscay by Robin Pingree and colleagues. So it wasn't just the technologies, it was having a real impact on the physical oceanography being done in the UK. But there were still lowlights. We were still deficient on the ship positions in many instances until the advent of then intermittent GPS. The limitation on heading accuracy from gyro compasses became increasingly obvious, and we really couldn't go on with the stepper gyro signals and the sonar pod on Discovery, and those were soon changed. Overcoming the gyro errors needed a new form of GPS, that of attitude measurement, and the early adoption of the technology from Ashtec using an array of 4 antennas on Discovery, 2 up here above the bridge and 2 on the foredeck here. And these enabled us to plot out and establish, really for the first time, what the errors with the gyroscope were. And so here, for instance, as a function of the gyroscope heading is the error in degrees. So going from about -1.5 here at a course of 180 degrees to -3.5 at a course of about 20 degrees. And these were really important. And so in the Bellingshausen Sea in the Southeast Pacific, this form of raw current map from the Doppler profiler could then be turned after a number of steps of correction for the heading errors, then gridded, smoothed, and interpolated into a map of this jet that's the south polar front in the Bellingshausen Sea, again by my colleague Raymond Pollard and the physical oceanographers were truly delighted by this form of measurement using corrected position data and gyrocompass. So it's part of a system. But the ADCP and the Doppler profiler is far more than just a tool for current profiles. These are current profiles in the Strait of Gibraltar, made on board Discovery for my colleague Harry Bryden. Informative in themselves, showing the tremendous shear between the upper and lower layers here. But when you add backscatter, it really does become a most illuminating picture of what is going on at this interface between the Atlantic water on top and the Mediterranean water underneath. And here we have the internal bore passing this point at the narrows of the Strait of Gibraltar. The sudden increase in current, the sudden dropping of the interface between those two water masses, and then the internal bore proceeding along. And this backscatter really does bring to life what's going on in the physics. Keeping on the physics and the backscatter, for a number of years I had truly delightful pleasure of working with colleagues from the biology group at, by then Southampton, Howard Rowe and Sophie Fielding, and with physicist John Allen, trying to interpret acoustic backscatter and relate to other measurements, such as the physics and the optical data as well. And we soon learned that we had to really delve into the biological knowledge about the animals that were present, not just from abundance and biovolume, but using scattering models produced by Tim Stanton and his colleagues at Woods Hole to predict what the backscatter would be, given a knowledge of the distribution of the animals. So this top pane gives the density structure in the upper ocean from 0 here down to 350 meters. And really it's quite a smooth function, very well behaved. But over that same area, just look at the complexity of the acoustic backscatter. There are very fine features within this, just a few meters in vertical extent, but very long in the horizontal. And some features you can relate to the front from the density up above. Some features you may be able to relate here to the infrared backscatter, which is really showing scattering from very small particles of phytoplankton in that part of the upper water column. But we only can guess at what's causing this complexity and small-scale structure in the acoustic backscatter. So this is a tremendous tool to give you images of the ocean so that you can ask questions about what might be happening.